today we're gonna make basically the entire encoding of the Huffmans. We stopped on session 1 calculating the probability, and today we're gonna start calculating the entropy. And actually, I think it would be nice to explain what exactly is an entropy.
Okay,
Because
entropy
this
is
is
the measurement of chaos.
it's a measurement of chaos, measurement of
Or
energy. It's
of
kind of
information also, so
complicated
this
to
Wait,
is
explain.
nice.
that's too abstract, man.
There is a fun fact. Okay, I'll tell a fun fact here. Entropy is actually the measurement of how much information a data carries.
Oh yeah,
So,
that's a good definition.
because the more chaotic your data is, the more information it carries. So
Yeah.
basically, you have this account, which is the weighted sum of the probability, and this will calculate the entropy of your whole system. So this is a fine way of seeing the things. Basically, entropy of A would be equals the sum of, it's a weighted sum of its probability time its personal
Entropy.
entropy, which you can see here. It was defined by Shannon. It is log 2 of 1 over the probability, which is the same thing as negative log 2 of the probability.
Where?
Oh, you're not seeing my screen, right? We are on Wikipedia, sorry.
Yeah,
If you go
Wikipedia
to
page of the
Wikipedia
Huffman
and
coding.
example, on the special example, I'll paste the link here. In general.
Just be aware to not share something sensible.
Share on the Huffman channel, man.
Oh, nice, okay. Okay.
But just be aware, Paradas.
Oh, okay, that's fine. You should go to example, and inside example, you can see down there you have the
Oh wait, what about
definitions
me
of
sharing
entropy.
the screen on Discord?
Okay,
No, that's okay. I can
yeah, it's
actually take a
better.
look.
Oh, okay. Oh wait, sorry, man. I haven't saw you were sharing on Discord. Sorry,
Yeah,
Yeah, we
yeah.
were
Oh
following. I
man.
was following Paradas.
Oh,
Here,
sorry,
I'm
bros.
sharing.
Okay, now I'm
No problem.
streaming Discord.
Okay, so basically, that's what an information content is. So that's basically what entropy is. It is log 2 of 1 over the probability of that character appearing. Not only
Yeah.
character, but here we're using for text-based stuff, so it's a character.
Yes.
Which can be also translated to negative log 2 of the probability. You don't have to put 1 over. Which
Yeah,
is
yeah.
good when you do math
And then
in
the
computers.
entropy of the entire sequence
System
of bits, you calculate it
the
as a
weighted
sum.
sum. Yeah, but a weighted sum, you must multiply it for itself for the probability itself before.
Yes, and
So
the
you
minus
get
comes
this.
from that fraction because the HAI in the previous equation, it is log 2 of 1 slash probability, right? To get rid of the fraction, you put the minus, and then
Exactly.
this is why in the capital H
So
entropy we have
here,
the minus there.
yeah. So here we have two things to do. First one, it is figure out how log2 is used in Rust, because I have no idea. And second one is decide, will we use a functional pattern or a C-like pattern? Because in C-like pattern, we could simply do a for and do the sum. In a functional like pattern,
You could
we
do a
could
fold.
map it, yeah, or a fold. A fold is even better. Exactly.
I'm 100% into the fold. I don't know about Nata.
Okay. Foldable Rust.
I
And
think
we
we
also
have to like go to an emitter and then we have fold, but we cannot do it in
No, but
like
that's
an
fine.
array for.
okay. So how to do log math log
yeah.
in Rust?
Let me just see how fold writes.
Okay, so there's a function inside a.
Oh wait, what exactly do we want to sum? Like is already like how can I
Okay,
say
so
a
if you
collection
go
of
to the Wikipedia
numbers?
page. Yeah, because we have the probabilities at this point in time. We do have the probabilities, right? We
Oh,
want to calculate the capital H. So what we need to do is to do a sum operation, like a fold or a for loop, and then we start summing up the probability times its log in base 2.
Exactly.
wait. If you want like uh either way, like only the sum of the thing first or later, I'm pretty sure we have a method like only for that. We don't really need to do a
But it's
fold.
not only a sum, it's a weighted sum, so we have to map the elements
Oh,
also.
okay, okay. You
It's
really want to fold it.
yeah,
Yeah, we're
exactly.
gonna basically like we have a few options in this particular case, but what I would do a map of the elements themselves to multiply by the log of them, and
Yeah,
then I'm gonna do a fold of the tree.
let's just try to see if VS Code can help us here. Let's see if it has some nice stuff. We
In the
don't care
meanwhile,
about
I'm gonna search for how to do the
teacher,
log.
right? Do we care about teacher? Not teacher, like sorted or not in
Wait,
this
wait.
case? No, because we're
Can you
doing.
repeat what are the requirements of things that we want right now?
Okay, we need a way to calculate the log in base 2 of something, of a float f64 number. And we need to decide how we're going to do the sum operation. We have the imperative way of doing it with the for loop, and we have the functional way of doing with the map and a fold.
Wait, wait.
Yeah, we have a fold here. So how does this fold work? What
Can
do I
just
need to
pass
pass?
the
Okay.
closure. No, no. First initial state, then closure receiving two things: the
Initial
accumulator
state
and the
is
current
0.
element.
The initial state is 0. The accumulator also starts at 0.
So you can
Um,
just use pi and put like the variables. And
No, yeah, but I think I'm in a different fold here.
no,
That's
you
fine.
have two variables. Uh, and then I don't remember if it's like space or comma, but we can try.
Element accumulator. Then we do accumulator plus equals
now we need a log,
element.
right?
Yeah. I'll just write log here just so that we know.
Do you know how to do this, Nathan?
Wait,
Log of
wait.
element.
No, not really.
It's minus
Okay.
equals actually.
Wait, but that's the assignment thing, right? You only need to return the thing, like accumulator, like minus the thing, right?
Oh, that's true.
No assignment.
Okay, I found it. There's
But
a
this is
function
not an
called log,
assignment.
apparently.
Oh yeah, it is. Yeah, it does apparently. No, it's a
No,
node
log
here.
2. It has a no. It's a log. It has the function in some module. I don't know how.
Oh,
No, it's
okay.
in a primitive. No, it's a primitive inside a primitive type f64. You do have log2 as an
Oh,
option.
so it is a method of the.
Yeah, it is a method apparently. You're
Oh,
gonna do
okay.
element dot.
Oh, nice. So, Paradas, like you are returning this expression, right? After the parameters. So
Uh-huh.
that will be the next accumulator. So I guess you can just like accumulator minus, right? Minus the
Hmm.
element. Like, so that would be the
Yeah,
next.
yeah, I agree.
Okay, that can we print that? I kind of want to
Oh,
print
wait,
that.
wait. I have something nice about the printing. Can you like put what you want to spec between parentheses? No. You can go anywhere. Like the value that you want to inspect. Put this between parentheses. You don't need println. Just put between
It's in here.
parentheses. Yeah, you can delete
Man,
this.
Like this.
Visual Studio Code is telling me the
No,
types.
it's like the result of that you want to. Okay, you can put between parentheses and then you will use like the thing here. Let me put on VS Code and you can like. Oh fuck!
Oh, what the fuck?
Wait, I have.
I know I'm opening a terminal, so then we can try to compile this thing.
Oh, I thought it was
Okay.
me. But hey, you
Yeah.
can just do like this here and expression here, and you can do that anywhere. He will like uh print this as a debug 3D printing. That would be the equivalent of this in println, if I'm not mistaken. Wait, I forgot.
Okay.
Like this, I guess. That would be the pretty print of debugging or something like that. Not entirely sure. But
Yeah, I
then
think it
he
is.
would print and then return the value. So you can. Holy fuck! Is it you doing that or is it me? Because,
No, I am the one manipulating the terminal. Just ignore it.
oh, that's so weird. But okay, then it returns the value. So you can put that anywhere. Like Just
Yeah,
put
but
that
I don't
anywhere.
like it.
That's
It's
ugly as
ugly,
fuck, man.
man. Yeah.
That
That's
what?
terrible.
That's ugly.
No, that's for debugging. That will not stay on the code, man.
Oh, okay.
You
Let me
see,
put just
so
entropy inside
you don't
here.
have
Let's.
to do. Yeah,
Yeah, I
sure.
could put it here, right?
But yeah,
Because it
the
would
value is
return the
not
element.
you putting like this. The value is like you
Yeah,
putting.
it's put in here.
Yeah. Then you
Yeah, I
can.
understand.
Yeah, that's nice.
How do you compile this thing again? I already kind of forgot.
Cargo run, you can like compile and run.
Yeah,
Okay,
but
but we need
cargo,
to go
cargo
to main.
build. Cargo build.
Okay, so what's the name of this function? It's calculate entropy, right?
Yeah, and you pass
So
the
I'm gonna
probability.
pass the probabilities.
Oh,
Uh,
wait, the function is completely wrong. I'm not returning F64. Let me just return anything.
Return 0 then.
Yeah, 0.0.
Okay, which is pretty fine. Okay, so
Okay.
it's cargo
I
what?
think it's correct now.
cargo run if you
Cargo
want to
build.
build and run. And
Run,
cargo
yeah.
build and.
Okay, so LSP is complaining about this thing.
Yeah, because we are returning and not founding this scope. What the fuck?
Yeah,
Let's
which is
see.
pretty interesting
Calculate
to say the least.
underline
Oh,
entropy.
it's complaining about the log2.
Oh, that's
Oh,
true.
can't call method log2 an ambiguous numeric type. You
Oh,
must
Entropy.
specify a type for this
Oh, that's
binding.
bad, man.
oh wait, is it
Okay,
because you?
accumulator is
Oh,
a heap node.
no,
We
wait.
are inside heap nodes.
Oh, okay, yeah, you have to.
Okay. Oh, this is good enough, I guess. But heap node, how do I manipulate heap node?
Heap node, you have to do like it's in line 7 right
No,
here.
just dots.
Oh, dot probability.
Oh no, but that's the accumulator.
Oh, wait, we have a problem. Symbol, UA, probability. Okay, let's just rethink this, because this is wrong.
Why is this is wrong though?
Because we need to return the accumulator. No, this is not. The element is not a.
No, it's not a heap node. It's just accumulator. I got it.
Yeah. But, oh, okay, this is on the
Oh,
opposite side,
yeah,
man.
okay. I
Now, now this
I
makes
was not paying
sense.
attention on that, man.
Okay, good, good, good.
Oh my.
Okay, so each element dot probability. Okay,
Probability. Yeah.
okay, that makes sense.
Element dot
Oh my.
probability dot log2. Is that okay though? Order
I'm
float
waiting for
at
LSP to
64.
complain though.
By the way, you
And
don't really
save here.
need. Oops. Wait.
Oh, it was me. It was me. Just leave it. Yeah, I know I don't
Okay.
need this.
Okay, so this complaining about this. Okay, it's not complaining anymore apparently, so we can try to save. Okay, main is also not complaining. I'm gonna run it then. Let's see.
Oh, I think we
I'll go
should
run.
build
It's
before.
building stuff. Now LSP is complaining, and now we got an error.
Yeah, I thought so.
No
Not
implementation for
Oh.
float. Oh
minus ordered
no!
float.
No, but that should be easy, right? To get the floats from the ordered float, probably just dot
Oh man,
something.
but this is so dumb. Why the heck the ordered float doesn't have like numerical operations and stuff? Ah.
Yeah, it could have implemented these, I guess. Yeah.
Okay, so how do we implement the num type class in here, Paradas?
No, wait. I don't think we need to extend
Yeah, I
this
don't think
type,
we
man.
need
We
also.
just need to dot
I think we
something
have
to
the
get a
value.
float.
Oh,
Look, we
dot.
do have the log2 function.
Wait, what I'm saying, let me try
Oh,
to.
there's a sub. There's a sub method here in accumulator,
No, no,
according
but
to LSP.
Oh, no.
accumulator is a normal float, right? What I'm trying to say is that where we have this ordered float type, we probably can get a float from this. See?
But I
Oh,
don't
you're
like
talking
that.
about the whole element,
No,
whatever. Yeah.
Yeah,
no,
to be true, I
element
hate it.
dot probability, you probably can do dot something and just like get the
But I
thing out
don't
of.
think we should.
Well,
Oh, well,
it's
do we have something?
Yeah, we could do something like element dot probability. Oh wait, let probab equals element dot probability
it
as
could be the whole thing, right?
F64
Oh,
probably.
what is this? Is this a
Oh,
casting?
yeah,
Yeah, this
this
is
is
a
the
casting.
casting, man. This is the one, man. Not the one that you were saying the last time.
And then you do stuff here like this and this. But I don't know if I prefer it this way I think only one person should change the code 4 times
Oh
on
yeah.
the same function.
Let me just
Because I almost changed it
watch.
on the changes. I think
Okay,
this
so
would work,
let's
but I
Paradas,
don't like how it is.
you'll be the one writing then.
Yeah. As expression can be converted primitive type to course specific trait or object. Okay, this won't work. Then
Try with the dot something. Oh, let me see on the card.
muti ref t. I don't like ref t.
What? Wait, 0. Is it? Oh man, is this a abstraction leak? In that this is like a tuple with one element and the dot 0 is getting the float from there?
Oh, that would be bad.
No, bad
Uh,
from them. Good for us because we could do this dot 0.
Oh, we have a function called into inner
what
that
is that?
it takes the inner like it's an
Inside the
ordered
outer shell?
code of
Get
the
Inside the shell?
yeah we it
Oh,
yeah we
get
have
the
the
value wrong.
inner yeah it is a 64 then it's fine the inner
Just for
type
curiosity, can you also see the dot 0? What is the return of the
sure
dot 0? No. Literally 0, like
Yeah,
the digit.
accessing an array, right?
No, a
like
tuple.
that
Yeah,
oh yeah
it is
the
the same.
value okay this is better than the other
that
one
should
This
that
is
should
really bad.
that should be private. Probably the type is not as private in some way.
I don't know I think that's fine though
I also
but
Okay,
okay I
propagate the
let's try
think
to
this is
entropy with
compile
that.
more
then.
idiomatic right
Yes.
Let's try
and
to
then we
compile it again.
but I think it's wrong
Which part?
it might be
Okay, so now it's complaining about not found in this scope again. So am I writing this thing wrong in here? Calculate
Oh no,
entropy.
unused in part.
no this is
Oh,
error, calculate
oh.
entropy probabilities not
Oh
found
wait,
in this
are you
script.
like importing quote unquote the thing?
Do we need something say like
Yeah,
let?
dot like that. Let me.
Oh, okay, do that then.
Oh, okay, because you didn't open the thing. Oh, okay.
Yeah.
Oh, okay, I
But
didn't know
you
that.
can open on mod, like up there, you can like colon and then the name of the thing, or just start to import the
Yeah,
thing.
but I think this way it's fine. It's
Yeah.
good.
Okay, so it's building whatever that is. Okay, so the
Huge.
entropy is 1.55.
How do we check if this is correct
We
though?
well we can check that manually. I have a calculator here. So we
Okay.
have text dot text
Oh.
test dot text.
Uh,
uh, and the probability. Oh, the probability is also in here, so it's easier. So it's 0.416 times log in base 2 of this number minus, right? No, it's plus and then everything is minus at the end. Okay, so it's plus 0.33 times log in base 2 of 0.33. And finally, there's also the plus 0.25 times log and then this. What's our answer? Our answer, oh, this is correct. Nice.
nice. Okay.
It's
Uh,
oh, but it's with the wrong signal though, I think.
it
This
should
should
be
be
a minus.
positive or this should be positive or negative. I don't remember
Hmm.
anymore.
I think it's negative. Positive, because probability the log of a negative value times uh yeah, I think it's correct. I think this should be positive.
Oh, this should be positive, yes. It should
Yeah,
be
because
positive.
this log will return a negative value, and this is a positive,
Okay,
and we
so we
will
have a
update the
way to
signal.
calculate the entropy. Nice.
Yeah.
Let's save this. So this will be the entropy.
So
Okay.
I quite don't get yet how to actually like indent this thing here, but I think
Oh,
this
how
is
to?
good
This
to
is with
know.
Nathan. Nathan, do you know how to
Now,
ident this thing?
what do you mean by dents?
Linting.
Like the yeah,
We are
exactly. But
using this already, right?
yeah,
Do you
exactly.
have
We're
the
using a
Rust?
linker. Yeah, no, it's fine though, but I
Wait,
don't
wait,
know.
Okay,
wait.
so
What exactly are you asking? Can you try to rephrase it?
No, no, this is fine. Because I tried to link it manually, and I still don't get like
No,
the
that's the beauty of
the
it. Like,
convention.
that's the beauty of it. We don't need to know. Like,
But I like to know.
Yeah, I also like to know. Okay, so next step.
oh wait, then
Next
it's
is
easy. What we are seeing on the screen is the convention because
Yeah,
it's what the default format is doing.
yeah. It does make sense. I just think it's a bit hard to read, like that we are doing into iter then folding.
Oh,
And what is the function of fold? Like I don't like putting two-line functions inside
well,
of a
you
fold, but I
could
don't think we have.
wait,
We
wait.
could
You
do.
could do
We could
something.
do this.
You could do a line just for the closure,
Uh,
just for the anonymous function, and then you attribute that to a variable, and then you do a like really short line, like
like this, I can do a function like this.
wait, I cannot see. But I'm not sure if you even need the fn. I guess you need the fn for a type, but I don't know if you need to. But well, let's try this. And just copy and paste.
They will ask me to say the type better.
Can you run Lemos?
I think
Like
only
this one?
building would work.
Better. Let's call just check, like cargo check. He will
Yeah.
check the thing without actually like building
Can you
it.
take a look at the Discord? I think Lemo sent some messages.
Or
Yeah. Let me take a look here.
having some problem with.
He got a blue screen. He's waiting Windows
Oh
reboot.
no.
Yeah. Let's wait for him.
Okay. Can you just like run meanwhile the cargo check?
Sure. For some reason, I'm not able to control S though. I
Oh,
don't know
that's.
why.
Let's see if I can.
Can you do that?
I'm not sure. I just press it, Control S, but I don't think it's will
Oh,
save.
cause he fell, man.
Oh, okay. He was
We
the
can't
host.
do anything. Yeah, he was the host. Okay,
Okay, I
let's
see.
wait then. Oh, can you like stop the recording for now until he gets back?
I don't think there is a point on that. You can just like
Okay.
stay here. Uh,
Yeah, that's fine.
Especially because if we stop and start again, that will be like other stream, especially on the VODs. See? The records of
Makes
Twitch,
sense.
they will be like two different things.
Then it makes sense.
Especially because like Lemos uses that recording to put on YouTube. So he would have to like do some addition, to, like put two parts to.
Okay, that makes a lot of sense.
Hey, but we can tweak the format later if you want to. I'm pretty sure you have a configuration file for the formatter that we're using. Let me take.
I think we should change the name closure to
Yeah.
this is the real calculate entropy. But accumulate local entropy, maybe? What
Don't
do
know
you
what
think?
would be the. Oh, okay. One of the things that I like the most about Rust is that fact of everything being integrated, like top-notch tools and like really integrated stuff, man.
Yeah, that's true.
You download like one thing, an extension, and then you have everything that works like really well and it's really integrated.
Yeah, this
It's
is
so
pretty
nice.
nice, man.
And for creating and running projects, you have like no problems at all. Like out of the box, the thing just
Oh
works really nice.
man, you're
That's
here.
true. Hey, you there?
Oh
How you
man, that
doing?
first blue screen like 5 years.
Okay,
That
that's a Windows 10. You have to
is
Yeah,
admit.
totally
it
a
is a
Windows thing.
unique Windows feature, man. This is a feature. You guys
Man,
just don't
but
see it.
I took a photo. It was saying like kernel panic, man.
Yeah.
Why?
And we need you to share again your
Yeah, no,
previous video.
I'm still rebooting my things here because
Oh.
like my computer, my whole computer shut it down
By the
Yeah,
way,
for
man.
some reason.
oh my. By the way,
Can
I
I
will.
commit here or not? Or is it
Sorry?
impossible? Can I commit?
No, I don't think you can because your guys we are manipulating the code in my computer, right?
I
But
see.
you can if you want. Like at the end of each session, we commit, and then for instance, next week, the next session, someone else can like share the code in your local machine instead of me.
Yeah, that's fine, but I don't think it's needed though.
Oh man, that's
Uh,
unexpected to say the
hey,
least.
I'm also like sharing on Discord, so if I need to show something for you guys, for instance, if you take a look
Okay, so
here,
go to.
Paradas,
Let me take a look.
so they say it here, the default format, they are following the Rust style guide, and the thing is like pretty serious, I guess. Like, see here,
Oh, okay, yeah.
but you also can tweak stuff, right? Yeah, apparently you can just create a file and then like use this command to see the options available. So we can tweak this thing.
No, but it's fine. I think it's better for us to get used to it anyway.
Okay,
Okay.
so I'm trying to initialize the sharing thing again. So, but Nathan, go to the GitHub that I shared in the Huffman chat, please.
The GitHub?
There, yeah, the one that the implementation in Python because I
Oh,
can't
sure.
explain because I'm still reloading my stuff. So this is like now we're gonna go to the main point of the entire thing. So this is the new. Oh, I don't have the link yet for some
Paradas, be
reason.
aware that you are sharing your screen.
Yeah, I
Yeah.
know.
Okay, so can you guys go to the extension and try to log in because you guys are appearing here to me. At least Paradas is still appearing.
See if I can log in.
No, but I wait here.
Join.
I have to
No,
click the link again, right?
no, I'm generating the link for you, Paradas again. Okay, so this is the link. I hope that my computer stays up this time. Uh, like I said, never saw that before. This is the first behavior that is. This is the first time this behavior appeared to me.
Uh,
Okay, so back to the point.
Oh wait, I will just share the thing that you ended in.
Okay, so
Trying to.
the next step is basically the algorithm itself. So what's the algorithm?
Can
What's
you
the
see my
algorithm that I'm
screen?
talking about? Let me check if I
What is the file?
can.
What is the file that?
why didn't? Oh, I'm so
Okay, go to main.py, and
open
then after we
commentary.
calculate the entropy on line 21, I'm calling a function called encode, right? So this is where the magic is happening. So I think it's actually easier to go to the Wikipedia page to explain this because there's a
Oh, I
really good
can.
illustration there.
Yeah.
Scroll
Nice.
down a little bit. There, this one. Yeah, this is basically the algorithm that we're going to implement right now. So,
Oh
uh,
man,
but instead of counting, because in the step two, Paradas, are you following us?
not really.
Okay, so go to Nathan's screen. I think it's going to be easier because he already has the algorithm basically explicit here.
Just I'm kind of not in good terms with.
Oh wait, let me also see something. Like if I go to
Save.
page.
Okay.
Yeah,
I
apparently
think
we
I'm
have
in.
people here, but we were not really paying attention.
Yo.
Oh my, we are such bad hosts, man.
Yeah, but the purpose of this is just recording, right? So
Yeah,
if so, later we can
we can
deal with
improve on that, but let's go.
audience, right? Okay, but Paradas, are you watching Nathan's screen now?
No, I'm still. I still can't log in the session. I'll watch not on screen.
Oh, you
Why?
okay? I can help you with that
Why?
later. Okay, so go to that illustration, Nathan. Okay, so you're watching now, right, Paradas?
Yeah.
Okay, so Nathan, in the second step, do you see that we have the character C and the number 2, right?
Uh-huh.
This number is actually the probability, but without dividing by the total amount.
Oh,
We
okay.
could do that if you actually wanted to. But we are following like the more formal approach, as far as I can tell, that we are calculating the probabilities themselves and then the entropy. You could, instead of doing this, just counting how many occurrences the character has, the byte.
What we had before, right? Before
Yeah,
calculating the probability.
and just imagine that these integers, like this number of repetitions, is basically the probability.
Okay.
So what we're going to be doing? We're going to be you like gluing the two least probable bytes, and then we're going to sum their probability, and then we're going to do this until we have only two symbols, let's say, because in the step 2 we have 6 symbols, right? We have C, B, underscore, D, and A. In steps 3 we have E, C, B, underscore, D, A. So this is like symbols. It's almost like a dictionary, you know. And then we're gonna still doing that. We're gonna continue doing that until the point that we have only two symbols, and that is on step 6. At step 6, we're gonna have the entire tree, because this whole process of combining the symbols themselves is creating a tree, right? So at the end of the step 6, we know that we're gonna know which bits we're gonna use depending on the branches. So every time you go to the left, this is a bit 0, and every time you go to the right, this is a bit 1. And then step 7 is basically having the dictionary. And then after step 7, you go to the original sequence of bytes in step 1, and every time you see an A, you put 1 0. Every time you see an underscore, you put 0 0, and so on and so forth.
Yeah.
And a really really cool property of this algorithm is that you're never gonna have collisions, right? You're never gonna have like two sequence of bits that can potentially represent multiple characters.
That makes sense.
I'm not sure if it makes sense. Like we trying, we can see that, but I, I
No, no,
cannot
no,
see
but
why,
no, it's
right?
not about trying. This is a property of the tree.
No, no.
The
Yeah.
tree itself has this
What
property.
I mean is like me going to the beats here, especially being like colored, and seeing that I cannot match in the wrong way. I can see that, but I cannot see why that's like the
Oh yeah, the Y, it's a little bit of like a huge jump,
you see.
because you need to, like, I got this like when I realized that this is a property of the tree. This is where like binary trees start to seem cool to me, because this is an embedded property that the Huffman algorithms explores inside the binary tree data structure. So for now, just for now, I think we should go with a more pragmatic approach. So I don't even have the knowledge to explain to you why this is the case with the tree.
Me
I
neither,
don't
but I
remember the
can.
I
Next
don't I
session, I
don't
will
remember
come with that
the
info.
explanation anymore.
Next
Uh,
session, I can come with that info, but that's true.
but this is a property of the tree. So paradas. Now we can try to go to find your problem with your invitation.
No, I think I got it now.
Oh yeah, it's working.
Yeah,
Yeah, I don't know. Let me try changing the main. Do you guys see? I wrote a hey.
I'm also trying to join yet. But it appeared for me
Nathan,
changing the
Nathan
role.
joined it.
Did,
Nathan is saying here that you joined it.
Oh, okay, nice.
do you see the changes in the main function?
Uh, what
I
is
put a hey on the end line.
No, I'm not seeing any hate.
Oh, okay. Then I'm not joined. Let's join. Continue as anonymous.
I do have another link though, so maybe this helps.
Please.
Okay, so here's the link. I'm starting to guess that the problem was, like, this is just a theory. The problem was using the shared terminal. Apparently, my CPU got, I don't know, too many people controlling the terminal.
I Oh, okay, the blue screen, right?
Yeah,
I think I'll be able
kernel
to join
panic.
now.
That was not.
Okay, no messing with the terminal, folks.
I can share the screen
Oh,
to
wait,
show
wait,
you
wait, wait,
compiling.
wait. Nice. Joining.
Okay, joining.
I think I broke everything, man.
Oh, your problem,
Okay,
Paradas, was probably because he was trying to save the file or like
yeah,
joining the other session, but he was not able to.
exactly.
And Nathan, from time to time, please tell us if someone is crazy enough to watch.
Yeah, now I remember that I can see like on OBS, right? So I can see the chat here. Oh wait, maybe it can even
Okay, nice. Then let me do my testing here that I was doing on calculate entropy. Just a second.
Feel free.
Accumulate local entropy. As I said, I don't like this. Let's see if I can. Okay. And it press accumulate local entropy. I think this is prettier.
Oh yeah, I
Is
also think that's better.
but that
But
compiling?
Oh, you need
let's.
you need a terminator on the let. Oh no, not there, not there because you are returning. But you need
Here?
after, yeah, after the let.
Oh
Okay.
yeah, it makes sense. Okay, let me put it here.
Okay, in the meanwhile, I'm gonna open a new terminal here and see if this thing compiles.
Oh,
Okay,
you
good.
you do outside VS Code, right?
Yeah, yeah,
Yeah,
I'm
that's
opening.
better.
I'm opening. Oh, but let me share the screen so you guys can also watch the whatever.
We are using a bunch of network, right? Because everyone is sharing the screen.
Yeah.
Oh man.
Vivo is not
Uh,
happy about it for sure.
I'm just
okay.
following paradas.
Okay. So let me Ruffman, and then we're gonna do cargo build, cargo run actually. Okay. Okay, so it's complaining about. Okay, so this is the file is not saved. Let me save this file. Can I save the file? Okay, I saved the file.
Yeah, the weird thing is that I think that paradas cannot save. Can you take a look?
Okay, but it's
Yeah,
still
I
complaining
need.
though. It's still
Yeah, I need
complaining.
to define types, right?
Yeah, I
This
think
here should be
consider
an
giving disclosure parameter type.
Ah,
64, and this here is a hit node.
oh, I was not aware of.
Node.
Oh, but okay, makes.
I
Okay,
saved
so
here. Try to run.
okay, it didn't save here, so apparently we are another synchronization problem.
Yeah, I think
No.
maybe you need to. Uh, oh, okay.
Okay, it worked. We are not printing
Oh, okay,
anymore. You
yeah,
could
that's
print.
nice. But hey,
Okay.
Lemus, I guess you need to like do some kind of permissions things for paradas for him to save the file.
But he's not read only, man. He's also write only. Why the heck he's not able to write?
Let
Don't
me
you
try
have?
saving main. Print line. Oh, I'll do the bug. Just because my friend here told me it was nicer.
No, 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 no. You can do the print, man. I'm just
No,
saying.
I'm not doing prints anymore, dude. This is
Yeah,
the bug.
Oh yeah, no,
that's
the
nice.
bug, the print is worse. The bug, being smart as it is better. Okay, so the file. Oh, now you saved it. Now you saved it.
Yeah, but I need to save twice, I guess.
What
Okay,
the?
nice. Try running now. Let's see if it.
Okay, try running.
Oh, probably was just taking some time, paradas.
Are you sure this is gonna work? Because the debug is being like entropy equal debug. Is this gonna work?
Yeah,
Yeah.
Yeah,
it works.
that's the good part, Lemons.
Oh, so these short circuits.
No,
Oh,
no,
I
no, not
see.
short
No, it
circuit.
did not short circuit. It just printed and returned the value.
Yeah, yeah, but
It is
this
a
is short
macro.
circuiting the print, you know? Because
Uh,
usually the like if you try to type a print is usually unit, right? But this is basically like pick the value, print it, and then instead of returning the actual return of the print, is returning the input.
Yeah,
So
this
it's
is the
short circuiting
power
the
of a
print.
macro.
one detail. Take a look on the output. We are not only returning the value, but the expression and the
Yeah,
value. Because
the
that's a
line also.
macro. That seems like
Yeah,
your
macro is
Oh.
code.
awesome, dude.
Oh, okay. So this is a macro.
Yeah, like
Oh,
I'm
look,
not sure if all of those, but some of those that you see like the exclamation point after it is like invoking the macro thing. Not sure the
I
proper
think
name.
the
Expanding?
exclamation point means for macro. Yeah, it's expanding.
Oh, okay.
This is pretty nice. I think the way that they implemented it might be very easy also.
Okay, so let's continue with the whole thing here. So now we need to do the encoding process, and that's basically to make the tree, Nathan.
Have we
Okay.
have sorted? We have the probability sorted already?
We are. That's the
Yeah,
thing. It's already sorted by nature of the tree.
Oh, the heap, right?
exactly.
Yeah, the heap is already sorting us, but it's kind of sorting in the reverse way in this particular case. Because I think what we actually want is the min heap, not the heap itself. Now that I think about it, and
But
I think I said it wrong then in the previous session
we
because
have that collection, right?
no, we do, but I remember seeing like heap and min heap and purposely speaking heap for
Oh,
some
okay.
reason. I don't exactly remember why. Oh, I think I do. Because in Python, when you pop the heap, you actually get the last one, I think. Yeah.
Mm.
Oh yeah. Okay, so we need to understand how to get things out of the heap. So let's explore LSP to understand how to. This will be. Oh man, like I don't know Paradas. Do you want to make the encoding in this file heap.rs? I want to create a new
Uh,
file just for it.
yeah, but I think calculate probability should leave also. Calculate
Should
probability, calculate entropy.
no? You think they should leave from here?
Yeah, someone
Oh
fell.
Folks, I don't
What is
even
that?
think it makes sense to have a file named heap, man. Like,
no,
Hey,
because we
just
have.
from the heap implementation.
oh, okay,
This
yeah,
Yeah.
okay, that part makes sense.
Okay,
and
so
all this here should be
encode
on encode.rs.
encode.rs. Yeah, that seems fair.
I'll create here then.
Try to create it. Let's see what happens.
Oh, yeah, it
Created.
does take some time, but
Nice,
you are
nice.
able
So
to.
Control X here, Control V here. I
But I
have
think
to,
we're gonna need to import a few things.
yeah, but and also mod heap, right?
Yeah, and also the heap itself.
Could use heap maybe.
What? Sorry.
Huh?
Could we use heap maybe?
Not sure what.
Oh wait, what the? I think someone.
What?
I'm not doing anything.
Nobody's touching. I'm not touching the keyboard.
Yeah, this is weird, dude.
Maybe it's just the network, like.
Like how do I open a module?
Oh, I
Like
you
that.
do, no, wait, no. You do like colon and then like star to open all.
Like that?
I think so.
We
Mm,
are not doing that in
No,
main.rs.
no,
We're
that's opening
definitely.
all. Uh, oh, okay, use. Oh, is that you? I don't know. Actually, I don't know. But we can
I
take a
think it
look on
works.
Rust by example.
What are you trying to do, Paradas?
Open everything on
Open,
scope,
yeah,
not
exactly. Open
only
qualified.
importing like
Because if I
Lemos.
didn't open qualified, I would have to put heap inside of
Yes,
everything here.
yes.
I don't want it. I don't think it makes sense.
So you don't want to open it qualified, right? You want to open
Yeah,
it
yeah,
like okay.
fully open.
Yeah, okay. So in oh, it's because in main we need to do that, like heap column
Yeah.
column. Right?
Yeah.
You don't want to do that. Okay, let's search. Let's search how to do
Oh,
that.
Uh,
this in main will also change. This will be in code. This will be in code.
Lemos, when we
Save.
save the thing, you can like try to build the thing.
Yeah,
No,
try
no,
to
but this
build
is
it.
this is this will not compile, right? Or it will
Yeah,
compile.
I'm
it
not
should
sure.
compile. It
That's
should
Okay, let's
compile.
try.
That's
Let's
the
try then.
problem.
wait.
We
I cannot.
didn't change.
Oh, now I can see your screen.
Okay, so it's not no, it's not compiling, saying that use of
Oh yeah.
undeclared create
Okay,
of
okay,
module.
okay. Yeah, we should put mod encode. Okay, try to compile now.
Okay.
Save it for you actually.
By the way, I can see that we take some time on that building process. You could leverage the check commandment because we don't really need to build a thing. Like we don't need to generate any.
Okay, so it's saying that it's not finding the types from heap.rs apparently. Yeah, a bunch of errors related to that.
Oh, but they are all inside in code.rs. Which are the ones that we need to pass there?
We need,
Collections,
yeah, we need binary heap. We need,
ordering, ordered float, and iter2s. Let me
yeah,
see.
we need also those. No, but it's complaining about the binary, heap node as well. So it's actually this is not
Try now,
working.
try now, try now. He will warn us if you're not using anything.
And you need to repeat what you said about compiling, Nathan, because I didn't get it.
Wait, just one thing. I think Parados, maybe it's
Same thing.
because like you are importing the other
Oh,
one.
use create heap. Oh, wait, man. I know. Create heap.
Oh, okay. I
Everything
see.
problem.
I was
I
reading
don't
about.
see. Can somebody explain to me?
Let me just see if it works here.
Let me see. And that's kind of.
Oh, nice. Okay, let me
I'm
take
not able
this
to
off.
explain this to you easily, Lance.
Let
No,
me
no, no. But
see.
now it's complaining about private fields
Oh,
in line 27 in encode. Okay, so here apparently no here yeah 27 here.
oh, maybe you need to
It's
declare it explicitly as public. Oh,
No,
oh
wait.
wait. Try doing it again. That was the only thing.
yeah, that
Okay,
was the
these
only
three
error.
we can take it off, right? We only need ordering iter2s and binary heap we can take off. We only need ordered float.
No,
Okay.
but it's still complaining about private fields.
But that's fine. I think we can access it in another way, maybe.
We
But
are.
can we should probability be private? Can we just put pub here?
Like,
Maybe?
it's already a pub struct, right? So how?
No, but the struct is public, not exactly.
Oh,
Okay, try now.
he's not complaining about syntax, right?
Yeah, try now. I put it a pub in front of it. Just
Which
like
is
we do
rather
in
weird. So
Python.
if this works, the struct can be okay. No method name unique for found
Okay,
vector.
yeah, I probably need iter2s here.
Yeah, you need
This,
iter tools here.
Hey Lemus, but what I was talking about is that instead of running cargo build, you can run cargo check
the other one doesn't need binary
because
heap.
you don't actually need to build our project, just should
Okay,
type
so
check.
cargo check.
It needs
Okay, so are you
iter2.
picking the iter tools to the encode.rs paradas?
Yeah, I placed it there and
I'm not
saved it
seeing
now.
it.
Oh, it should be there.
No, wait. Maybe it's the network. Oh man, it is the network. It's so damn slow. Okay. Cargo check. Let's see. Okay, so apparently it checked. Just for sanity check here. I'm gonna build it. Oh yeah, I can trust cargo check.
It's much faster,
Uh,
right?
yeah, but I can't trust it
Okay,
because
no. I know what
Oh, you
happened now.
can't?
I took off
I can't
binary heap
trust.
from here. But
Yeah.
this is so fucking weird. It was saying that it was unused, but that's fine. Try again.
Okay.
And
Are
we are
you?
using iter2s.
No, but are you sure you pasted in encode.rs?
Mm.
Because we
Oh, I
need
didn't.
the binary heap here.
It's true. It was saying that we didn't though. Try again.
No, but that in no, but it's complaining about that in heap.rs, not in
Yeah,
encode.rs.
I know.
Okay, so you added it in encode.rs. Okay,
Yeah.
let's try cargo run. And now it's complaining about private again. So this is because this needs to be pub.
Which one needs to be pub?
Inside the heap node struct, we have a pub. Now I'm adding
Okay,
a
right.
pub for the symbol itself. Okay, so you can have public structs, but the fields themselves are not. Okay, it worked.
I guess it makes sense, man.
Yeah, I
No,
agree with that.
I don't know if I agree with this.
Like, I'm not sure if it should be the default, you know, like being private, because for modules it makes sense and for structs, but not sure for fields. But it makes sense because I want to have an abstract data type. So you don't know what is the implementation of that, you only know the methods.
Yeah, I like that.
Okay, so apparently we can remove binary heap from here. I'm gonna try that just to be sure. Um,
Wouldn't
let's see.
he like warn us about unused stuff?
He did that here.
Oh,
Okay,
okay.
nice. That's awesome.
Okay, so now we can continue doing whatever we wanted to do.
So we need to create the tree now, right?
We need to create.
Does
We need
this
to.
tree have a name, a specific name?
Let me
Don't
see.
think so. Uh,
I'll put create Huffman tree. What do you think?
yeah, create Huffman tree seems okay.
We need a probabilities, which is a binary heap.
We need the probabilities. This is the only thing that I'm doing in my Python implementation.
Where is your Python implementation?
It's
I
in
know the
the
link, but
Huffman. It's
You
oh, you go to
paste on my
you go to main.py and then you go to line 24. There's an encoder.encode and then you click that to go to the definition. And then the first step is saving the original symbols to return only the used symbols. Oh, I know why I did this. I remember. I can explain. It's because at the end we're gonna have a tree composed of imaginary symbols because they are glued together. This original list that I made was because I wanted to save just the symbols that I will be encoding at the end. So because I will manipulate, because everything in Python, everything is a pointer, right? So you need to do like copies from copies and whatever.
Oh, okay. You have two of those because you are mutating the second.
Yeah, the first one is because I want to save the original one. Okay, so I want to save the original symbols, and we have the symbols inside the probabilities because each heap node is a probability and the symbol itself. So original list is basically like just to have the original symbols. And then symbols dict is the one that I will actually manipulate to make the tree itself. So they are basically copies from it. They are basically the same thing but different memory
okay.
regions, right?
So first, let's create this Huffman code function, which is exactly what it does.
Okay, yeah, the Huffman code function. Okay, let's do that.
So we have the probability, and we might need also the symbols dictionary, which is the same thing as the probability.
No, the symbols dictionary is basically I don't remember anymore. Let me take a look. Where I'm using this symbol dictionary.
You created saving the original symbols for future manipulation inside
Oh,
encode.
I know,
This
I know,
was
I
the
know.
one.
I know what I'm doing with the symbols dict, right? Okay, so the dictionary is to know is to add the new symbols, right? The symbols that we are gluing. So if you go to line 12 on this file, the def Huffman code, you see that you have the probabilities and the symbols dict. The symbols dict is basically saving the new symbols that we are creating by gluing things together. So if you took a look at line 28 and 29, you see that I am adding to the symbols dict. I'm adding using some sort of manipulation, right? So I'm concatenating new symbol, whatever that is, with bytes. So I don't remember why I'm doing this now,
No,
but
it makes sense, but what is this? What is exactly the symbols dict?
is
It's symbol to string.
it's using the from keys. So dictionary from keys Python. I don't exactly remember anymore, but this is a really popular function.
It takes item one. What the fuck
Hey
is item
folks,
one?
be right back. Be right.
Okay,
Okay,
that's
so
fine.
why item one, you may ask? Because the item is a tuple, remember, is a symbol and a probability, and we are using the probabilities in this case.
Okay, so it's symbol probability. That's
Yeah, it's
basically what
probably
it
the
matters.
symbol. It's probably the symbol, and the from keys returns a dictionary with the specified keys and the specified value. So I think I'm removing. I think I am removing. Oh yeah, I think the probabilities. It is already a dictionary. Okay, the probabilities. So it's a symbol related to a number, and the number is the probability. So I'm not using tuples in this specific case. And then the from keys function is extracting just the symbols from this dictionary. Okay?
Mm-hmm.
Okay, so then in the Huffman code function, what I'm doing with those. This is a recursive function, as you can see in line 35. So it's not as easy to grasp. But let's go. So in line 14 to 15, I'm basically doing the base case to end the recursion, and that's when we have less than two symbols, right? Less than two symbols with
Oh wait,
probabilities.
I think we have a problem here. Let me just uh, try to get it with you. So this symbols dict, we are passing it to the Huffman code, right?
Yeah, we need the symbols that we're
This
gonna
is the
encode.
second argument. This is
Yeah,
a string to int map, right?
this is a string to int map.
Or to float map, a string to number map, right?
Not entirely sure.
Because we
Not
are
entirely
getting the
sure.
probability.
Let me try to print here.
This Python kind of.
Okay, so this is a string to int. You're right.
Yeah,
This is a string to
okay.
int map.
And
Okay, so
when
let's
we
say
go
no,
to
but
Huffman code, let me just finish this explanation here right now.
no,
When we
but
go
start
to
from the
Huffman
beginning because
code,
Nathan is back.
okay, so this symbols dict it's basically the list of symbols that we are using.
Yeah.
Uh, and there is a problem with this right now when we go to Rust, because if you see, we created basically copying the dictionary that we had before in probabilities. And if you see the Huffman code, the function itself, the second argument, right after it, like inside here, symbols dict, it will take lowest one and put new symbol plus bytes 1 UTF-8. So basically, this is a byte. This is not an int anymore.
Okay, but let me try to explain to Nathan the purpose of this whole function. So, okay, Nathan, what I'm doing in the Python implementation is the following. We have the probabilities and we have something called symbols dict. The symbols dict is basically a dictionary relating uh, a symbol and a number. Okay, and why I'm doing this, I remember now why. Because I'm doing the encoding. Because if you take a look on the image that I showed to you previously, the image with the tree, there we have the feeling that the tree is happening. You do the encoding after the tree. So you first make the tree completely, right, until you have two symbols, and then you do the encoding. So encoding would be left 0, right 1. Okay, but in my implementation, I'm making the tree and I'm encoding at the same time. I'm doing this like in one single pass. And this means that we need a way to accumulate bits, right? And I'm using the dictionary for that. The dictionary is accumulating ones and zeros. So the way that I'm doing it is I made a recursive function called Ruffman code. This Ruffman code function picks a probability and the final tree. You can imagine the symbols dict as the tree itself. Okay. On lines 14 to 15, this is the base case of the recursion, is when we have less than two probabilities on our set of probabilities. Because only two probabilities would mean two symbols only. This is the end of the recursion. If we are not ending the recursion, this means that we have more than two symbols, right? So we still need to concatenate them. How we concatenate two symbols? We pick the ones with the least amount of probability. So I'm calling the lowest and the
Oh,
second
okay.
lowest, and I'm popping from the heap, right? The heap of probabilities. And then I'm creating a new symbol, a symbol that will be the gluing these together.
Oh,
But
wait, wait,
because
wait. What is that? Lowest 0 and then.
yeah, because this is a probability in a symbol itself. Remember, it's almost like a tuple. So we have
Oh, okay, I see, I
so
see.
we are summing up the probabilities and we are gluing the symbols together to create a new one.
Okay, so the left part of the tuple, is it the symbol?
Good
And
question. I don't remember anymore.
okay.
Okay,
Uh,
so look, here is the string type. This is basically the new symbol. If lowest was A and second lowest was B, this would be
No,
AB.
yeah, until
And
that
the
point.
right part, this is the sum of the probabilities.
Yes,
So if
because
it
I'm
was
putting.
0.5 and 0.5, this would be
Yeah,
1.
exactly, exactly. And then in
Good
symbols
choice.
dict on line 28 and 29, I'm actually adding, I'm already transcoding this thing to the bit representation with ones and zeros.
Yeah,
Right.
so we basically take the probability and add a byte.
By the way,
Uh,
Paradas, I don't think the byte would be a problem in Ruffman. We have the bytes. We can use like
The problem is that symbols
UAs.
dict. Oh yeah, but symbols dict. It's first for a float and then it turns into a string to byte. It is heterogeneous.
I am starting to think, Paradas, that the string is the one. So lowest zero plus second lowest zero is the probability, and the one
Mm.
is actually the string itself. So lowest one plus second lowest one is the symbol, the new symbol. And then what we are doing, we are going to our tree that I'm calling symbols dict in this case, and I'm adding this guy as a node, and I'm actually already generating the bit representation of this node. Because I always know where to put the one and where to put the zero, because the lowest always goes to the right on the tree,
Oh yeah,
and the second lowest always goes to the left.
but here, just
Right.
here.
Okay, let me watch your screen now, Paradas.
Symbols dict of new symbol one, and then you assign a string, but an empty one.
Yeah, that's the thing I'm not getting it actually.
Of the
Does
lowest
it make
one using.
sense for us to try to translate this Python code? Maybe it's better for us to think more
I'm
about the.
actually I'm actually in favor of creating a new one from scratch. We can
Yeah,
create
I
a
think.
new, completely new logic. This is I just wanted to explain this because it is so short. It's like 23
Yeah,
lines
it's
of
very
code,
easy.
and it's recursive, and it works.
Yeah, but it is a bunch of mutation, right? But,
Yeah, no, it's mutation hell. It's like only mutations. So, what do you think, Paradas? I think we should be capable of creating a new thing from scratch instead of looking at
Yeah, I
this.
agree, but I think we should take a look at what's the name of it? Dynamic programming. It might have some nice answers for us, but I think we should understand this first.
I do agree that understanding these would definitely help. So, but that's the thing, I don't remember anymore. So define values of the lowest ones using created symbol.
Yeah, but that's the point. Like this new symbol one is AB, for example. AB plus 1 byte, and this AB plus 0 byte.
Oh,
Oh wait, it makes sense.
yeah, can you explain to us?
But I think. Oh man, but I think no, this cannot be it actually. Do we have the link here?
The
Let me
link for
grab
what?
the link. For the tree, for the
Okay,
images that we were
it's in the
looking
Huffman
before.
channel in the Wikipedia link.
Huffman. Okay, this here.
And that's the thing, I made that and I already forgot.
oh,
Okay, so
that's so
look,
funny.
basically, what is going on there? Uh, we are storing inside the tree what is the actual value. Not this. We're storing this here inside the tree, right? Do you
Yeah,
agree with
we
me?
are already creating the speed
So
representation.
yeah, so for example, instead of D10 here, we would have D01, right?
Yeah.
Oh, okay, so basically what is going on here, what I think it's going on, but it might be wrong. The new symbol plus the byte is basically the new symbol. Is this one? This is the new, okay, let me grab down one. This one, and then
Hmm.
B, so the value from the CB, oh no, wait, I'm wrong. New symbol one, lowest one plus second lowest one.
I'm 100% certain that this is related to making the bit representation in one single shot, because I didn't want to, at the time I didn't want to do two passes, right? One to create the tree and another one to get the bit representation. I was doing both at the same time.
But I
I
don't think
remember
that's a
that,
problem.
but I don't remember exactly how I made that work. I'm pretty certain that the lowest one is basically creating the symbol like CB, you know? This is like CB, and then we
Yeah.
are already creating the representation. Right. But I don't remember the
It's a
details
problem.
anymore. What is new
Maybe you're
sim?
storing inside the symbol, man. Which is
Can we actually run and inspect this Python code?
We can actually we can run it, but I don't think it's worth it. I think what we should do, because we already have that tree, we have already the abstract representation. We should keep this in mind because maybe this will help, and we're gonna have like a eureka moment in, I don't know, the near future. But I think we are capable of making our own implementation from scratch, especially because we have things like folds, we have things like a continuation pass style, so we can do the two things at once.
You
We
had
can
yeah,
those. You had all those things in Python.
you
um,
didn't have the mentality, man. That's the thing.
Oh, I see. I see what you're saying.
Oh, I think here, okay, let's create a Huffman tree. Well, all I think we need is the probabilities, and we will return a Huffman tree, which is a binary heap node.
Isn't
Or,
probabilities a misleading
or,
type? Because you have the probability. Well, you have the
no, it's
symbols.
a binary heap of the probabilities, it's correct. But I think the return type is different this time. I think we should return this.
Oh, no,
Basically the
what I
mapping.
mean is, take a look on
What do
heap
you think?
node.
Sorry, can you repeat, Nathan?
Wait. Go on first, Paradas.
Okay, so for this last function, this create Huffman tree, I don't think we should return a binary heap. I think we should return this mapping here,
Mm.
which is a character to a bit representation. Because we actually don't need this
Yeah, we don't need the
for
tree.
now.
That's the thing. We don't need the tree.
We only need this, right?
Oh, so I
Yeah.
totally
We
agree.
can
We
skip
just
this.
return the
We can
mapping.
return, yeah. But I don't know how to do a map here.
Uh,
Uh,
Wait.
That's a good question.
Yeah, we have to think what we will use. But what I was talking about, Paradas, is take a look on what is the type of a heap node.
node, the type itself.
Yeah, like control click.
We could do a map, right? Changing the symbol to its binary representation. That could also work.
Like, is fair to call that a probability? Like, yeah,
Yeah,
sure.
it is.
Have the symbol and the probability of the symbol. But
Yeah, I think it is.
calling probabilities. Yeah, yeah, I guess it's fair.
I think it's fine, man. Here, I think, let me just hash map Rust.
Oh,
That's what
wait.
we are
Oh, I
using.
discovered. I just no wait. I don't. No wait. I
Oh.
didn't. I didn't discover anything. Go on.
Yeah, we are creating hash maps. Yeah, I think it's where hash map. Oh, we can create simply tuples, list of tuples. Oh, but I do prefer hash map a lot, man.
Yeah, but would be. No, but that's a
I think we are
hash map,
returning
but
hash
you are
map. Yeah,
creating from that, right?
yeah,
So
we are
for instance,
returning hash map, man. Hash map string. We don't have string like that, right? It should be like that.
uh,
And you
no, I
wait.
guess we want the other string type,
Do you think?
maybe.
Okay.
But
I think we only need a character type actually.
oh,
I like that. You wait. I think you only need one bit. Like, you wait is fine. It's fine.
No, but are you thinking about using what? Sorry. Hash map of a chart to U8.
Yeah.
I don't like that approach. Because we're gonna have to use masks later, man.
What for?
Because a U8 is basically like you are saying that the map will map a char, like a byte, to 8 bits, but you don't want to do that.
Don't
You
want
want
the
to
whole
have,
8-bit, right?
yeah, you
No,
don't
yeah,
want
I
to.
agree, but what is the other
The
solution?
other solution to use basically strings. That's, I did this in like C or C++ and
Oh,
Python,
okay.
and then later we make a function that converts a string made up of ones and zeros to a actual bit representation.
Oh
Yeah, I
my
agree with
god,
that. Okay, I agree with that. I agree with that.
that's
Because you're gonna
so
have to
cool.
add padding as well.
Yeah, yeah, I agree with that.
We're gonna have to add padding at the end,
Okay,
which sucks, but
separated
it's
is
part of
very
life.
awesome.
Like when we're dealing with really low level representation of things, we start to get these problems of, oh, we're gonna use masks and we only want 2 bits, but the minimum amount of an integer is like 8 bits or something like that.
Yeah, I agree.
The only thing that I could think that Rust could have, maybe Nathan knows about it, is actually like can Rust represent like a proper unit bit?
I don't think so. Uh,
Yeah,
don't we have something called like bit field in C? Do you folks know what is that? Bit field?
no, I
No,
don't.
man.
Just
Maybe Rust has something better than this, but I don't think. I think this is good enough for now.
I also don't think it's good enough.
just search a bit.
Okay, so inside of it, I think we should have a helper function that will do the recursion for us.
Can we have a function
I
inside a
don't
function
think
in
you
Rust?
can
Yeah,
do that.
I think we can, like closures.
No, no, I don't think. But let's try it.
Like here, that's exactly what we have here.
No, it's not.
No, that is not the same syntax, man.
No, but it's
No, no.
pretty much the same thing. We can change
I'm
syntax.
pretty
That's what I
sure
said.
that we have like some differentiation, some
No,
difference
yeah,
between the
I know we do.
closures and those like top level functions.
No, I know for sure we do, but I do think like we can change it for this if we can do this. We
Well,
just need the
the way
functionality.
is testing, like running.
Yeah.
Yeah, we can run it and see what happens.
Okay, so Huffman tree helper. What we need? Let me think. It's right here. What we'll do this step by step. Don't I have like this? Yes. So first, check if we only have 2 elements to return the hash map. Okay, so in the helper function, the hash map will be passed by reference probably. Check if you only have 2 elements left. If true, return the hash map.
Yeah, otherwise we start doing recursion, right? Recursion.
Uh,
Oh, there's a problem though. Because this create Huffman 3, if you're planning on using recursion, we need to have a dependency to accumulate the hash map.
something like that.
No, but we
Ability.
need to pass that. Yeah, we need to pass that through the recursive function.
Can we accumulate hash maps?
In Python, we just updated. We don't actually like accumulate them. We update them. I don't know if you can do the same in Rust, but it's worth a shot, I think.
Lowest will
Okay,
be.
so this is where you do probabilities.pop. Let's see if you have pop. No, no, use LSP, man. This function
I
exists?
mean,
Pop?
yeah,
Holy.
but it's for option.
No, but removes the greatest. No, but that's not what you want. Removes the greatest item from binary heap and returns it. Okay, so we don't want a heap. We want a min heap, which is set
Oh,
AF. But let's go. No, but this should be quick because I think it's just changing a word. Go to heap.rs, and instead of making this,
oh, it's not here. It's on the
it's not
other
here.
one.
It's in encoders. No, where the heck are we
So
creating this? Heap
here,
node.
calculate probability.
Calculate probability. Okay, so this is not exactly what we want because we want a mean binary heap. I searched about it already. Mean binary heap Rust.
I think you can even see on like VS Code, like on opening the collections, writing part, like where you have like binary heap, can autocomplete and
Mm,
no, like
Oh,
delete binary heap.
this is ugly as hell, man.
Wait, I'm not sure. Oh, I'm more.
No.
Oh, okay,
Okay,
I'm watching
Paradas, you
Paradas.
need to see this.
Let me watch Lemos.
No. I don't have anything. Go to Paradas. Paradas will be the
Oh,
one looking at this ugliness. Look at this, man. And scroll down to see the implementation of the mean heap.
array.
Read that. Read that comment.
it
Which?
It's doing the heap is the same, but it's
Oh
reversing it.
makes
no!
sense though. I like that.
No, man. Please. Oh no.
What the?
You need
No,
to
no. How
reverse
does
it.
no? How does that work? Because it's reversing that. No, that doesn't make. Oh no. Lemos, I think you are seeing that wrong.
Okay,
No,
so
this is
how
true.
is
This is exactly what I found in here also.
No, take a look. Yeah, but come back there. Like reverse is some comparing thing. You are not reversing the heap or anything.
No, yeah, but you're putting the values in the reverse mode. So basically, when you
you're changing
compare the
the
reverse,
origin trait
you
apparently?
change the word. Hey guys, can someone lead for now? My mouth is kind of starting to ache a bit.
Oh, lead you mean code?
Yeah, exactly.
Okay, I can do that.
I'll be on here, but I'll speak less. I now got
Okay.
Dr. Vice here. Just a second.
Okay, so Nathan, you want me to lead or you lead?
No, you
I'll
did.
stop sharing here.
Okay, I lead. Um. Okay, so let me share the screen. First, let me check if I don't have anything that I don't want.
Oh, yeah.
I don't want to share to the
That's
world.
important.
Okay, so the only good thing about the computing bluing screen is that I basically close everything.
Okay.
So let me go to sharing my screen. Okay. Okay, so let's go. Okay, so what I think we need to do here, we need to push here, but instead of doing like this, we need to do the reverse trick. So I'm gonna copy this guy.
Wait. Why are you not using the? Oh man, no! Please don't do that. Uh,
What?
why are you doing this instead of using the actual type that we need?
What do you mean? Type that we need.
The way that they are doing is to use. Oh wait, that's the only way of. Oh no! Oh, now I know what you're talking about. I thought that this was the implementation that they were doing, but no, that's the
No,
way
there's
that.
no syntax sugar for this.
Oh man.
This is the way it's done. You have a single data structure that is the binary heap, which is by nature like the greatest at the if you pop you get the greatest, but because you want to reverse it, instead of creating a syntax sugar for it, apparently Rust just changed the trait,
Oh,
because this is basically what it's doing, at least
that's
my understanding.
actually like pretty smart, right? Like,
No, it's smart in terms of implementation,
but yeah,
but not having a proper like syntax for it, like, oh no,
we can
what are
like
you guys doing?
we could wrap this into something, but I don't think
Oh,
it's
not worth
worth
it.
it. Yeah.
Not worth it. Completely not worth it. Okay, so if you go to the code here, okay, so this is the function that Paradas was doing. So the lowest is basically this, and then we're gonna have a second lowest. So second lowest, and this will be probabilities also pop, and the pop in this particular case is getting us the least, like the least amount of probabilities. So here we have the symbol and the probability itself, right? What we need to do now is to, okay, I
There's a
lost
new
my,
symbol.
Yeah, we need to create a new symbol to create a tree. But I'm still bothered by this. I'm still bothered that I don't remember what these three lines are doing. Because if we get this, what this is guys are doing, I think we can like accelerate the implementation.
Yeah,
And
I
we
think I have an idea. But first, let's just create the new symbol and put it back to the heap. I think that's the best thing we can do.
okay, so let's do that. So let's create a new symbol now. So let's do let new symbol.
It is a new binary heap. No, a
Yeah,
new heap node, right?
yeah, it's a new heap node. I already forgot how to make one of those. So let's go
The
to
first function
here.
there.
Okay, so this is the way that we are doing. We are doing this. So the probability in this particular case is just a sum, right? It should be the
But it's still
lowest
an ordered flow.
Have
ether
options.
in into
No,
ether. Is that it? No, into
no, no,
inner.
no, 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 no. You should just grab lowest dot probability.
Yeah, but we have an option, right?
Yeah, we have an
Oh,
option.
we have an option.
We have an option here. So I think
Okay,
we
we
need to do a
can match both.
match.
Yeah, we can
Yeah.
match both.
How do we do matches in Rust?
Just match.
Okay,
Yeah,
match like
Match
this.
expression,
Match
and then
lowest dot no, just lowest and second lowest.
yeah, I'm not
Can
but
we
sure
I
do it
if
think
like
you
in
need to
pairs like
put them.
this?
Yeah,
yeah, I
yeah, I think
guess
you need to
so.
put them
Not sure if
inside.
you can omit the parentheses, but I think
And like with
no, no,
is
no,
with
no, no. You just use
Match.
curly braces.
oh curly braces like this.
And now, Lemus, you'll be stunned, man. Like, oh man, I maybe you'll be disgusted. Yeah, Rust by example. Yeah.
Oh, that's not that bad.
Look at
Yeah, it's
that
good.
arrow. Look at that
No, the
comma.
error is bad. The error is bad, but I was kind of expecting worse.
Yeah, I think this is fine also.
What
Uh,
about that comma, man?
Some X.
comma. Oh, the comma is bad. The comma is really bad. This is bad. This is actually worse than the arrow.
Yeah, the com is really bad, man.
You can also use like curly braces, and then you don't need the comma.
Okay, so let's match. Is this size great for you guys? Do you want it to
Yeah,
be?
it's fine. No, I think the other one was better.
Okay. Okay, so let's match some and then some. We're gonna have I don't know SL and L. Don't know how to call these. And now we can do create this like this.
Oh wait, what the fuck are you doing? Don't you want the let outside the match?
No, I don't because I just want to make the new symbol if I do have two sums.
Yeah, if you don't, you just fail the whole
Yeah,
function.
exactly.
Uh,
Oh, I
uh,
think you should just Control S and wait for it
wait,
to
wait, wait.
decide what to do.
That
I
simply
already did Control S.
Oh, it's just simply wrong, right?
like that
Oh, man.
doesn't make sense, man. Like you cannot have this let. Okay, you can have this let there, but you cannot return a let, right?
No,
No.
I'm gonna return the new symbol, but can I just format this thing?
Not.
Okay, try doing the following. Press enter after the arrow. Put the whole thing down after the arrow.
Oh, by the way, probability or not.
No. Okay. Yeah, it's probability. I know.
And instead of comma, this terminator use normal comma and see if it stops complaining as fuck.
Okay, so let's do probability. Now it's appearing to me. But this is a sum. So I actually need the no, but this is also wrong because this is oh man, naming. This is L dot probability.
Yeah,
SL dot probability like this. And the symbols and the new symbol that we want to make
L
is
dot
actually
symbol
L dot
symbol.
symbol. Is this a concatenation in
I'm
strings?
not sure. I have no idea. Take a look on Rust by example of string concatenation.
Rust. Okay, so
Oh, maybe you have dot concat or something. Oh,
Oh,
oh, it's
plus works.
push. Are you kidding me? Why?
Wait, 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 wait.
But
But
it
that's
depends on the type.
It
I
depends
think
on the
plus
type,
works.
yeah.
Yeah.
What's the type that we are dealing with? I already forgot. It's a
probably.
U.
You
Oh, it's a charmin.
wait.
It's a U weight.
Oh, what? Uh,
We need to convert this to a char. Can we cast it?
why is that a
No, it's
U8?
so bad. Like
Wait,
we
wait.
need to change
Let's no.
everything.
Let's take a look on this thing. Does it make sense to be a U8?
Yeah, it makes sense because this not necessarily is a letter, man. This can be like a byte that only makes sense in a series of
So it
bytes to
should be a
Unicode.
string, man. This is a string, man. Because we are transforming it later.
I don't know how to deal with UTF text in Rust, but I'm not sure if that's only using like strings. But we have it on the book. Go on the book, they have a part about like dealing with UTF.
Yeah, but should we change this paradox thing to a string? Because I know, like, it's in terms of representation, it's really bad.
Yeah, I agree, but I think we would get the most functionalities of it being a string.
Okay, so
Unless, yeah,
no, I don't think there's another option though.
yeah.
We could create a new heap node, and then like instead of
Yeah,
having a
or
binary trees of
we could
this.
also bind.
No, but I actually am not necessarily against this idea. What about having like a Huffman node?
But then we do have to implement word, partial word, and
Oh, that sucks.
yeah.
That sucks a lot.
Hmm.
Uh, isn't there any way to derive this guy from another guy? Like
I
this
don't
doesn't
think
make
there
any
is.
sense
I don't really know.
because we could do like I don't know, like this.
But I don't think we lose anything uh, using the other one as a string.
It's just bad because like this is a byte. Like this is a byte.
Yeah.
But anyway, we're gonna have to re-implement the other ones because I
Uh,
think they will break
hey
I
now.
think it
folks,
should be the bigger string type, though.
yeah,
So,
maybe the type it's really string. I'm seeing here they don't have another type or any special technique for UTF. They just use like the normal string.
okay, so it's a string. Okay, so how is this
This is correct.
suppose this is already correct? Are you sure?
Mm.
Because it's a vector of U8s, and then the element comes
Oh
from.
no, okay, yeah, you need to
I need to do something
extra.
like is a string or something like this.
Oh, I
Ah,
think string from element.
what is this buffer that?
No, this is no. Forget about the buffer thing, Nata. This is the function that we made to calculate the probability. But the problem is that we were assuming that the element is a U8, but now it's not
Oh, okay.
because now it's a string.
Let me see how you were doing the symbol for.
We were doing like this.
Okay, what is this element? Element.
Element now is
Oh, then buffer.
no, element is still a U8. Is an address to a U8,
Oh,
but we need to convert it to a string now.
okay. Maybe you can do like a string from, or maybe you wait to. No, 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 not dot. When it's like a static method, you use like the same things for namespaces. So colon from.
Okay, doesn't seem like it.
Uh, oh, we only have this
Yeah.
from you a.
Okay, so let's try
What about this
U8.
UTF-8? String from UTF-8.
U8.
No, 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 string from UTF-8. What
Like
is that?
this.
Yeah, what is that?
It's expecting a vec, like a U8 global, whatever this is. This type, the type of this is U8. This is expecting a vec U8.
That would be easy.
Oh yeah? Okay, let's do that then.
Yeah.
How we create a vector out of nowhere here?
I guess. Well, I'm not sure. You can take a look on Google. Probably.
Okay, create a
Not sure if
vector
you have a
Rust.
macro for that or if static method.
Actually, U8 to vec U8.
Probably just create a vec with.
Oh, to vec.
Oh my.
Okay, so let's try that.
By the way,
Two.
do we really need to like dereference this stuff because it has a lot of automatic dereference?
We can try to do without it. I'm not against it.
And I'll be very sincere with you guys. This kind of stuff makes me want to use dynamic languages.
Oh no, man. I would
What
say
the
it makes
fuck,
me want
dude?
to use like a higher level language, but not dynamic.
No, man, come on. Like, what the fuck? Why do I have to care so much? It's the same thing. Like, if it was a byte, I just need another addition, you know?
Yeah, I think it kind of
I
makes
need to
sense.
get, instead of an U8, I need to have one U8 after other U8, so like a U8 list. You put inside
How?
the same structure, and that should be
Lemus,
great.
we can try to guess like vac, and then you put like exclamation point, and then you open like brackets. But I'm not
Okay.
completely
Okay, so vec
exclamation.
this.
That work?
I have absolutely no clue. It's complaining though. This guy is still complaining. Um, Semicolon.
Yeah,
It's
because
saying
you are
that it's
trying to return a let, right?
um,
You are trying to return a statement, not an expression.
yeah, but
You want to
how
return
does
it.
that work? Because we are inside a match, so this should
That's
be a
that's what I
comma.
said. The let should be outside. Man, what do you want to do with this match?
I want to return a new symbol actually, like
Okay,
this.
okay. So then you return just hip node, and you forgot about the new symbol.
Oh, okay. So return.
Yeah, you don't even need return, and then you can use the comma.
What do you have against return?
Because you don't need. I'm not even sure if you can use. No, you can't use there. That would return the whole function, I guess.
Okay, but this guy is still complaining about whatever.
Yeah.
So
Then we have.
expecting string found string.
Oh, because the plus that you are using, I guess.
Okay, so is there concat in here?
Uh, yeah, you have to.
Append? No.
Maybe you need to clone on and
No,
push.
man.
Yeah,
Why?
because those things are mutable, man. You cannot
Oh,
push side
push
that
is
string.
string.
Yeah, but that I'm not even sure if
Yeah.
that's push as
Okay, push.
try just push
Push.
because I
This guy is expecting a no, but
oh
this
okay
guy's
okay
expecting a
yeah then
char.
it's
I don't
push
want to
yeah
push.
then it's push str right
But this is not the
no
type
no
that we
yeah but
have.
that's easy to convert you just do the normal string dot as str or something
Okay, this is oh man, this is so ugly.
as
As
str.
str.
Yeah, but then you have something. Not sure if you can do that because you are mutating the thing that you are matching, right? You
Um.
probably need to clone this symbol.
Oh no.
Yeah. Okay, I agree. That's really bad, man.
Okay, so how do we do that? We need to do a let in here?
No, no, the clone is just dot clone.
Oh no! Okay, so it's even worse. Okay, so dot
No,
clone.
no, no, not there. Not there. The symbol. After the symbol, I guess.
Okay. Okay, so clone.
Yeah, just clone and you call the thing.
Like this?
Yeah, is this working?
No, it's not compiling
Wait,
yet.
wait, but he's complaining about the lowest and second lowest also. What is that?
Missing
Oh,
match
yeah.
arm.
Okay, you are
What
not
is that?
man, you are not matching everything.
No, 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 but wait, you need to be patient, man. You need to be patient. Okay, so this is the first. Anything else is an error.
Fair.
How do we do this? Because
Uh,
oh, this is not gonna work yet. Because I think no. Wait, wait.
accumulate hash map. What is that accumulate hash map that you're saying?
This is the function that. No, but we can change the signature of this guy. Right? This is no problem.
Oh, no, but what is that supposed to do?
This supposedly would pick a binary tree of probabilities, pick the lowest ones, and then concatenate them, and then put back, and then put in this hash map.
Oh, that we would be using that in a fold, right? Some kind of.
Yeah, exactly.
Uh,
Some sort of a fold, yes.
let me just see. The thing that we are
Yeah, but this is not a
copying
char anymore.
are the probability.
Um, this is also this
Uh,
is a heap node to string.
I think it is a string to string.
No,
We are
it's not
having
because we are creating a new heap node with
but
the new symbol and the probabilities
wait,
combined.
folks.
which one will inside the same probability heap node? In the hash map, we only need the symbol.
Oh, that's correct. Okay, so this is a string to string. Go ahead, Nathan.
Yeah, I think uh, you can just take a moment on this function and you can create the code that will use this function because that way you'll be clear what we need on that function.
No, but right now we want to throw an error. This is why we are blocked because maybe we're gonna have a problem along the accumulation thing because these guys returns an options instead of returning the heap node, it returns the option of the heap node. So we need to take care if you don't have any options. This should never happen. Like this case here should actually never happen.
Okay, Lems, you have a few options. One of those possible ones would be after the pop, you can do dot something, I guess dot unwrap. No, not unwrap, but dot, and then you can like get the value or panic. You know?
No,
Uh,
okay. Okay, so this is the unsafe Haskell thing.
yeah.
Uh, unwrap.
No, maybe is it
Okay,
unwrap?
unwrap works. Unwrap
Oh,
works.
I thought that was only for results, but okay.
Okay, so now we just grab this and then just do like this, and this is the new symbol. New symbol, and then we do like this.
That's so weird. Like in some places we are calling hypno the probability, and in other places we are calling this a symbol.
Uh, okay, so we need a new name for this guy. I'm new node. Okay, so this is the new node. Now what we need to do is to pick the map that we are receiving as a dependency and actually append that new node to it.
Okay, that's
But
interesting.
the problem that I don't know if it's possible, Paradas, and I think this is the thing that we are missing from this code, is because we need a logic to start concatenating the ones and the zeros. Because this is basically this, right?
Yeah, but that's why we're using strings now.
No, no, but we need to know. Okay, so for instance, how are we gonna make? Because in the original code that I did, I am actually manipulating. I'm creating the representation of the lowest and the second lowest, right? And then I'm creating the symbol later in the same dictionary, so in the same hash map. So this line is straightforward. We already have the new symbol, and then we're just gonna we're gonna insert it into our hash map. That's fine.
Wow, you
The
can do the
thing,
same.
but that's the thing. We need something like it would be great to understand what is these two lines are doing, right?
Uh,
I kind of get what you're saying, but basically, what I think it is doing, or what it should do. Uh, no, I don't know actually.
You don't know. Okay, so let me make a theory. So the lowest ones, wait, the lowest
Yeah,
is always the one to the left,
but
and
that's
then
the
we are
thing.
adding a zero.
What I think you
But
should
I'm
do.
doing the opposite here.
Yeah, exactly. That's the point. Go back there. But that's not a problem.
Yeah, that's
What I
not a problem. Why this is not a problem, Nathan? If you go left zero and right one, or the opposite, the representation still have the property. Okay?
Yeah, you just have to. How can I
Just have
say?
to flip out all of those.
Yeah.
Okay, so go ahead, Paradas. You were talking something?
Go back to the image.
Go back to the image.
Okay, what I think we should do is uh, CB should be empty. Okay, in the first one should be CB dot dot empty string. C should map to 0 and B should map to 1. And then
Yeah,
when we go up one level, then CB would be updated.
yeah. No, but
Okay,
that's the
but that
thing. That's
doesn't
not
make
that.
sense.
Yeah, that's not gonna work because the symbol that this guy like, we cannot make the symbols. That's the thing that I'm not getting. How I made. I'm not understanding how I made this work because we are kind of generating the symbols from bottom to top.
Yeah, exactly.
But this is
That makes
shouldn't
no
be
sense.
possible, right?
Yeah, that's not even possible. I think we
No, but
should do this correct way with two
Wait,
passes.
wait. What is not possible?
because in order to, for instance, look at this symbol B here.
Hmm?
The symbol B is 1111. But you only can know this after you have the entire tree.
Okay.
But it seems to me that the way that I did, I'm creating the symbols without having the entire thing,
Mm-hmm.
which is really mind blowing. Like I probably the professor explained this during the course because I'm not smart enough to make
No,
this from
no,
my
but
own. My own.
you are creating as you go, right? Because you are just adding one each turn or adding zero each
No,
turn.
that's the thing. But if you see the probabilities that I'm picking the lowest. So this means that I'm picking the C and the B.
Uh-huh.
Okay, but then I am concatenating them, creating the CB here. But then I am already determining, like,
Wait, wait. Go back to the image. Because see that first tree that you have there on the second step, you will still have that tree on the last tree. It's just in a different place.
no, yeah, it is, but I do not know the representation
No, no,
of B
Oh,
only
I
you
was
with this.
speaking
you can
muted.
if you go
Man,
backwards.
wait. Yeah, exactly. And you do that on
Oh,
translate symbols.
oh, so this is the way I did it. So I'm concatenating C, B, and 1.
Yeah.
Okay,
What the
and then
fuck?
I am
But why?
transforming.
Yeah, but why? Right?
No, because after I have the entire tree, what is the symbol of B? Is the symbol of CB plus 1.
That's why you are
Okay,
translating.
so I am making, okay, now I remember. So I am
Okay,
making,
yeah, that makes a lot of sense.
I am creating the entire thing, but I'm already saving. Okay, B, your representation is this plus 1.
Yeah, perfect. That's perfect.
And then after, no, but there's a more elegant way of doing this.
I think this is pretty elegant actually, because B is a map to CB plus 1, and then
I
you
would
just simply
prefer.
unmap CB on the second passage.
Nathan, did you understand now?
Not sure about this function, but
No, not this function, but the idea.
yeah, I saw that you can know already. Like, but man, the thing is, I would prefer
No,
to iterate multiple times than
yeah, but we
doing.
are iterating multiple times. That's the point. We don't know what's going on there. This is simply a
Yeah,
string. This is a string that is basically the new symbol. So if it was B plus C, this is CB plus 1. So in
yeah.
the next function, what he does, gets the last character, which is a 1, and the value of the new symbol inside the dictionary.
Yeah, so okay, so let me paraphrase to you,
This
Nathan.
one, he goes bottom up. The next function, he goes top
Top
to
down.
down.
Yeah,
Yeah.
so okay, so this is actually a perfect explanation. So this function, Nathan, Huffman code, it generates the tree but from bottom up. So we start from the lowest ones and we start creating, like from the leaves, we make the parent and then we pick another leaf, create a new parent, and so on and so forth.
As the
But
inverse.
along, but we are doing these 3 lines here. What they are doing, they are actually already populating the leaves, and they are populating the nodes along the way. While we are constructing the tree, we are already setting which representation B and C would have.
Wait,
It-
you are not doing the tree, right? You are doing the map
uh,
already, right?
I am no, but this map is just
Yeah,
a different representation. But in your mind, makes more sense to think
Oh.
this is
as a
a
tree.
list. That's true. This is a list. But that's the point. You have a
Okay, but
list with all the nodes, not only the leaf nodes.
yeah. But then, Nathan, let's just finish the brainstorm. So we are creating the tree from the leaves, like bottom to top.
Hmm.
Okay, bottom up. We actually call this bottom up. So we have B, C. We create CB, and then E, CB, and then start going up.
Yeah.
But do you agree with me that regardless of how tall this tree will be, the representation of B will always be CB plus one.
Sure.
Imagine that this is a black box and we are like plugging this subtree.
Like, yeah, we already know the end of the.
Yeah, so this is what this is doing. This symbols dict is saving this information. What's information? What is the final representation of B? So let's read this again. What's the final representation of B? This is what this highlight is. I'm translating from this highlight to English. So what is the symbol, the final bit symbol of B? Is CB plus 1. Okay? And then you can ask, okay, but you don't know CB. And that's right. But then there's a auxiliary function that replace all the created symbols by their respective bit values. So Huffman code is exactly what Parada said. Huffman code creates a tree, like it runs across the tree, it builds the tree bottom up. And then after we have the entire tree, we have a bunch of symbols like that are nonsense, like ECB, CB, underscore D, underscore DA, ECB. We only care about the leaves. Because of this, we have another function called translate symbols that picks this symbol dict, which with random, useless symbols that are only useful for making to find the binary representation of the leaves, and we are parsing it again, the tree, but now we on the places that we have nonsense symbols, we translate them to their correct binary representations. So Huffman code, it goes bottom up, and translate symbols, it goes top down. So we are doing 2 passes here. One pass, we create the tree and the representations in terms of nonsense symbols. And then at the second round, we convert the nonsense symbols to actually bit representations. And you can ask why. How do you know the representation of CB? Huffman code is also doing that because it's saving in our tree, it's saving the tree the new symbol. So it's adding this symbol to the tree, and then in this context of the Huffman tree that I'm calling this tree Huffman tree. In the context of the Huffman tree, the nonsense symbols matters. Why? Because you need to know how they are configured to discover the bits representation of the leaves. So, yeah, Paradas discovered the mystery. So, yes, so one function does the creates the tree bottom up, and then our second function translates the intermediary nodes to bit representations so we can get the leaves. So it's a 2 round process. I do think it's possible to use function composition to do this 1 round though. Not entirely sure.
Yeah. One weird thing is that you are calling this a tree, but okay, I see that. I
No,
see your
but
point.
It is a tree.
No, no, on the
Because we also
Python
have the
code.
relation.
Yeah, the
Yeah,
Python is just a dictionary, right?
yeah, exactly. But it's basically a tree. We have the relation also.
Yeah, the relation is there's because the
Basically,
relation.
the new symbol is the relation.
Yeah. So
It
this is the
contains
way
all
that
the.
I'm. So let's see this. Okay, so I'm calling the Huffman code. So I'm making the tree with the nonsense symbols.
Yeah.
Then at this point in time, probabilities after we finish this function, probability has only 2 or less symbols, which means that I need to encode them by hand, right?
Yeah.
What I mean by encode by hand, Nathan, I need to decide this guy will be 0 and this guy will be 1. Okay. Um, so I'm doing this right here, and then there's a corner case that probably I discovered after a little bit of debugging. And then I pick the Huffman, I pick the symbols dict, and then I translate them. Fake symbols included. Yeah, so this is exactly it. So the symbols dict, it has fake symbols, like symbols that are useless for us. But then I'm translating them back, and then this for is translating is doing the bit translation. Yeah. Yeah, so yeah, this is the hash map. This original list at the end is the hash map that we are doing, that we want to do in Rust here. Okay,
Hey
so we
guys.
already passed the 2-hour mark, so
Yeah,
I think we should finish
exactly.
this. But next time, I think that what we're gonna do, we could use this approach, the same approach, if we really wanted to. But we have until Thursday to think of a better way to do this. So if you guys
Yeah.
have a better way to, like, for instance, if you could do, I don't know if it's possible actually. I said it, but I kind of said it before thinking about it. I don't know if it's actually possible to do in one way, because like we said, it's impossible to know the bit representation of the leaves without the intermediary ones. You need the middle ones, because you need to know how deep you go. This is the purpose actually, because these 3 nodes, the function of them is to you to know that B is at this level of the tree, and then it has 4 bits. So I think it's impossible to get around these fake symbols. We need them in some way, and then after we have them, now we have all the necessary information to have the bit representation. So I don't know if it's possible to escape this strategy. Yeah, but we really did reverse engineering here.
Yeah, it was nice.
Okay, so you can finish the stream now, Nathan, please.
Okay, just that's fine.
Not a lot of code done in this time around, but at least we
Yeah.
understand more of the Huffman thing.
Okay, I'm
Like
stopping the stream.
this